Hello, I'm Dr. Harper. This video is an Operations Management BANA 3000 Spring 2021 homework number 1. In this video, I go through the quantitative parts of the homework, not the qualitative parts. The qualitative parts are covered in the lecture video, but it's a homework video to go through how to set up the problems, how to work them through, but not all the way through. So let's bring up the homework assignment number 1. So in this first homework assignment, as we come down here, notice the first 2 questions here are right out of the lecture. And I say how many statements are true. And so I make a statement here, and some of these statements could be true, and some could not be true. And on this first one here, I have repetitive, process production, batch production, job shop, and then I have the type of industry, intermittent, continuous service, intermittent, and then I just match them up. Which one is correct and which was not correct. The purpose of this question is just to focus on the definitions. Likewise, on the operations strategy, the same thing as far as the different types of designs, and then you have different designs within the classifications. Make to order, customized, customers product focused design. And so what type of decision would be within those designs? So that comes right out of the lecture. It's just matching it up. Now, part 2, questions 3 through 5, this is quantitative. So what I like to do is set it up for you to show you how to set it up with using Excel, how to bring in Excel, how to set it up. I won't work it all the way through, but I'll work it. But I'll stop just before I get to the answer and let you finish it. Okay, so this one. A local company is considering 3 options in meeting demand. Option 1 requires no fixed cost and purchases the product from supplier at $1. The other options consist of producing the product in-house and reducing at a reduced variable cost. Option 2 has a fixed cost of $300 and a reduced variable cost of 50 cents per each product if you produce it in-house. Option 3 has a higher annual fixed cost of $630, but a variable cost of 20 cents per each product if you produce it in-house. So the 3 questions here is, what is the break-even demand between options 1 and 2? For the demand of $1,300, which option has the lowest cost? And then finally, how many of these statements are true? So I have a number of statements. So let's go through each one of these. And the homework is very similar to the exam, where understand the problem and then understand the answers and then the question. The problem, the answers, the question, put them together. Okay, so let's look at the break-even. First of all, what's the break-even demand between options 1 and 2? So let's work the problem. So let's bring in Excel. Let's bring it over here. Do this again. Let me bring in Excel. Here it comes, if I can get it in. There it is. Full screen this thing. Open Excel. There we go. And let's make this larger so we can actually see what's happening here. So it'll be easier for us to do this. Let's reduce it. Okay, here we go. Let's set this thing up. Let me show you how to set it up Excel. You open Excel and you come here. Let's set it up right here. Now what we're going to be doing is having different options. Options 1, 2, and 3. Whoops, 3. And then we're going to have a fixed cost. And then we're going to have a variable cost. And then over here we'll have the break even. Okay. Now for the first option, there's no fixed cost, that's 0. The variable cost is $1 right here. Option 1, let me reduce this. Bring it over here so we can go back and forth between these and not make ourselves dizzy. There we go. There we go. The option 1 has no fixed cost and a variable cost right here has a variable cost of $1. Okay, 0, 1. Okay, and then option 2 has a fixed cost of $300 and a reduced cost, a variable cost of 50 cents. So this is $300 and this is 0.5. And then option, let's bring this down. Then option 3 has a higher fixed cost of $630, and then the variable cost of 20 cents. Okay, so now, what is the... Okay, well, if you recall in the lecture, if you go back to the lecture number 1, that lecture I gave you the equation, and in the equation I gave it in the... let's go back to the... let's open up the lecture number 1. Bring it down here. We come down here to the break even, and here it is. So I give you the actual equations here and the solution and how to do it. So this is what I'll be doing in Excel. So let's reduce this, come back to Excel. Let's do this first one right here. So that's going to equal the difference between the fixed cost divided by the difference between the variable cost. Now I'll set this up, but I won't solve it. I'll let you solve it. Let me show you. First of all, the fixed cost. Take the larger one first, so it's a positive number, 300 fixed cost minus fixed cost, in parentheses, divided by open parentheses, and I go the other way, the larger variable cost, 1 minus 0.5. And so notice in Excel, if this is the first time you've used Excel, I start with the equal sign, and equal sign tells Excel I'm going to put some numbers in there, or cells, to calculate. Okay, and so notice blue is blue, red is red, purple is purple, green is green. So the cells are color-coded. I press return. That's going to be the break-even between 1 and 2. That's the break-even demand between 1 and 2. I'm not going to press return. I'll let you do that. And notice question says, 1 says, what is the break-even demand between options 1 and 2? Okay, and I'm going to do the same thing down here between 2 and 3. Equals is the equal sign, open parenthesis, and I'll do 630 minus 300 in parenthesis divided by open parenthesis the other way. 0.5 minus 0.2. Press return, that'll be the break even. So that's how you calculate that in Excel. Okay. Okay, next, let's bring this down a little bit more. There we go. Okay, the next question, for a demand of 1,300, which option has the lowest cost? Okay, so now I'm going to have, say, cost here, but this is going to be for a demand, let me say cost, for a demand of 1,300. I'm not going to say 1,300. I'm going to say, put a number 500. Okay. No, let's put something different. Let's put a number, let's say something smaller, 300. Okay. So what I'm going to be doing is finding the cost for a demand of 300. So this will equal the fixed cost plus the variable cost times the actual demand. And notice again it's blue and red and then purple. And so I press return and that'll be the cost. See, okay, I'm going to go ahead and do that. And so if I click that and go on the right, on the lower right, see the plus, I can left click and drag all the way down and I'll see, okay, that's a 0 and that's a 0, delete those. And you can see this is 300. Oops. Okay, it's not 300, it's a mistake. Let's go back and look at this. Let me go ahead and make this, let me make this larger. Let me go ahead and do it again. Equals the fixed plus variable times the demand. Now I want the same demand on each one, okay? So this last demand I'll F4 again to fix the demand, okay? And so the dollar sign in front of the F, that's the column, the dollar sign in front of the 3, which is the row, it's going to fix that. That cell is not going to change. When I copy this down, the red and blue cells will change. So I take this plus this times this plus this times this. Okay, so let me go ahead and do this with 300 all the way down, and now I can delete the zeros because 0 plus 0 times 300 is 0. Notice the cost for option 1 is $300. For option 2, it's 450. For option 3, it's 690. So this one here is 300 plus half of 300, which is 150, is 450. So that's what that one is saying. Question number 4. Now question number 5, well, then I do the same type of question, but I do it for which has the lowest cost for a demand of 500, 700, 900, 1200. Well, you use this very same template that I've set up for you. You'll put 500 here, and you'll see which one of these is the lowest. Is 1 the lowest? Well, for this one, 1 is the lowest. 3 is lower than 450 and 690. If I put 500, will 1, 2, or 3 be the lowest? If I put 700, which one's the lowest? 900, 1200. So you use this same template and put it in there, and you'll have the question for number 5, or the answer for the number 5 question. Okay. Well, let's go on. And so now 6 through 8 is using the same type of problem, but this is just a straightforward textbook problem. This is more of a real world kind of problem, and so I'm kind of getting used to doing it's progressional. So this is more of an application. A company is examining the cost of producing an item in-house rather than purchasing it from a third-party supplier for $79.50. So, you know, we use so many of these. It's getting costly. Let's just make it in-house. Let's just make it ourselves. And sometimes you can go to the supplier. It's called vertical integration, and just purchase a supplier and you make it yourself. It's going to be a lot cheaper than buying it. Okay. In-house production would require the one-time purchase of equipment of $2,400, but the in-house production would cost $450 per item. The demand for the item is a constant 10 items per week, where 1 year is 52 weeks. So this question says, what is the break-even in weeks time when the cost of the in-house option is equal to the cost of the outsource option to the third party? So essentially it's saying, what's the break-even in time? Not production items, but time. But the production and time is connected with this demand of 10 items per week. So let's bring back Excel, and there we go. Okay, and so let's set it up here. So this time, well, I can copy this over. Control, left click, drag, and copy it over. And so I'm not changing the first one. I only have 2 options here. I have the in-house, and I have the third party. Partay. There we go. And so this one we're not going to be doing. So the third one is not there. If I can get and do it. I keep going too fast here. There we go. Delete. So I have the in-house and third party. I only have 2 now. So let's collapse this down a little bit. And so now we come back here and say, what is the break-even in weeks when the cost of the in-house option is equal to the cost of the outsource option? It's the same idea. Okay, the break-even here is going to be the same. But the in-house would require one-time production of $2,400. So this is $2,400. Okay, and it only costs $450. Well, if you purchase third party, we're assuming there's no fixed cost, but the variable cost, the price of this thing is $79.50 per item, $79.50 per item. So if we purchased it from the third party, that's how much it cost. If we made it in-house, well, we have a big cost up front, but it's cheaper. So if we're going to be using a lot of these, then yes, it makes sense to make them in-house. If we're purchasing just a few, well, then this 2,400 is prohibitive. We don't want to do that. We'll just buy a few when we need them. And sometimes it's referred to as spot purchase. You buy it on the spot, just whatever the price is, you just buy it. Here is an in-house production. The question is, what's the break-even? And this is in demand. This is a break-even demand. Again, it's the fixed cost, 2,400 minus 0, divided by the variable cost, 7,950 minus 450. Okay. Now I'm going to, so if I return that, that gives me my demand. Okay. I'm not going to do that. I'll let you do that. Now, whatever that demand is, notice the break-even is not in demand, it's in weeks. And so there's 10 items a week. So if the break-even is, let's say, 50 items, how many weeks is that? Well, 50 items divided by 10 is 5 weeks. And so be very careful how you answer the question. Again, working the homework and the exams, reading the question, understanding the question, and reading the answers and then putting them together. The problem, the answers, the question, and then putting them together. What's being asked is the weeks, not the items. This gives you the items. You divide that by 10 to get how many weeks. Okay. And then question number 7, what is the total cost of the in-house option after 2 weeks? So what's the cost here if you have 2 weeks? Okay, well, 2 weeks is how many items? Well, there's 10 items a week, so 2 weeks would be 20 items. So I'm going to take these out here. I've already done this. I'll put 20 in there, and that would be my answer, whatever's in there. Now 7 is what's the total cost of the in-house? Oh, I did that. 8. Okay, like I did before. Now let's make this a little more problems. After 6 months, what is the difference in cost between the in-house and the outsource options? After 6 months. Well, how many, if it's 10 items a week and a year is 52 weeks, then how much is 6 months? Well, 6 months is half a year. How much is half a year? 26 weeks. If it's 26 weeks, 10 items a week, what's going to be the demand here? And what's going to be your demand is 260. So this is a little bit of a real world problem, a little bit step toward reality. It says, okay, you always convert back and forth in industry and business to make sure you're working the right problem the right way. Okay, good. And then you calculate this, and then down here, the question number 8 says, then you take the difference. So instead of 260, let me put 100 in there. And then let me just go ahead and say, see up here I said, okay, equals this plus this times this, F4, to fix that, and then copy it down to here. Okay. Now this is saying what is the difference between them. So here I would say this minus this, the difference between third party and in-house is that the third party is $5,100 more for a production of 100, a demand of 100. So I'm asking for the in-house option is after 6 months. The in-house is, so this one, the in-house is 450 more, 1710 less, 2250 more, and 450 less. Then you have to just kind of go through and that's how you work the problem. You do one at a time. And is it true? Is it not true? Is it true? Is it not true? Okay, for 6 months. So which one of those is correct? Or none of the above is correct. Which one of those is true or none of the above is correct? Okay, let's bring this out again and let's go on. Okay, now I have one problem here on the lecture. how to calculate a control chart. Now, there's a lot more information about statistical process control charts. This is just one simple way of doing it to illustrate how to calculate a control chart. But it's a really simple and kind of almost oversimplified, but it can be used if you have a really simple application. And this is one. And so let's say the days of stay in the ICU, intensive care unit, for the critical care of a disease is being monitored to determine the efficiency of future treatments. A random sample of the days of stay that is assumed to be drawn from a normal distribution is used to conduct a statistical process control chart using the mean and variance from the sample and use the population variance equation. So essentially from this sample, and this is 12 days, the sample, the days of stay, here's a random sample. We're saying, how would I construct a chart from that random sample, from the population? Okay, and so let's bring up Excel. And so let me show you how to use Excel to do this. Bring in Excel again. Here it comes. Okay, let's open another sheet. But this time, let's reduce this. So this time, let's take the sample here, Control C, come down here, and then Control V and paste it. Now, when you do this, it's in a row vector. And so when you start calculating things, Excel, some functions will work with a row, but all of them will work with a column vector. And so what you do is you highlight the data, Control C and copy it, and let's make this larger. Come down here, click, right click, and paste with just the values. Okay, whoops. And then Control C that, right click, and then come over here and transpose it. Whoops. Let me do this again. ED erases it. Let me do it the other way. Okay, Control C, come down to here, right click, and let me transpose it first. There we go. And then Control C, and then paste it again with just the values to make sure they're values. Because sometimes Excel will take a number and make it alphanumeric, you'll never know, and the answers are wrong. So that's just a safeguard. Okay, now we want the mean and the variance of the sample. So let's come back here, but I want the population variance. So right here I want the mean and I want the variance. And this is the population variance. Okay, so let's do that. I'm going to go ahead and do this for you. And that's going to be the average. And it's all these numbers. Left click and drag all the numbers. In parenthesis, return. And this is the standard deviation dot P. And the P is the population standard deviation. And notice you can have it S, which is the sample standard deviation. Open parenthesis, and we want the standard population standard deviation of all those values. In parenthesis, return. There's your number. Is that okay? Now that we have these numbers, let's do this again. Standard or variance, sorry. Variance dot P will equals variance dot P of these. I did the standard deviation. I was going to do it, but I went ahead and did it this way because now the standard deviation, let's say the standard deviation is the square root of this. Okay, and what I was doing there, I was kind of like skipping a step. I was actually doing the standard deviation of the population. You could do it this way too. Standard deviation dot P of these values. In parentheses, and notice it's the same number. So I took the square root of the variance to get the standard deviation, or I took the standard deviation population of all of this. So either way is correct. It doesn't really matter. Okay. However, this is the variation of a random variable. Okay. Now in the population. So now, what is the variance of the mean? Aha. That's going to equal this variance divided by the sample size, which is 12. Okay. And then the standard deviation of the mean is what we're going to be using here, equals the square root of that number. And that's why I was getting ready to do it that way. Okay. Okay. And there we go. Okay, and then so up here, let's come to the lecture notes again. I'm coming down here to the whoops. If you look at the lecture notes that I gave you, there we go, under quality control, and by the and notice it's the square root of the variance of the mean. So it's the mean plus or minus 3 times the square root of the variance of the mean. Variance of the mean, which is the variance, square root of the variance over n. Okay, and so here's an example. So let's do that with this. And so what we will do here, let me go ahead and set this up for you. You're going to have, to be careful here, you're going to have a mean, right? Then you're going to have your 3. Then you're going to have the standard deviation of the mean. Okay, and then you're going to have the upper control limit, the center line, and lower. Okay, now the upper control limit, and I'm going to put in here 1, 2, and 3. Now the mean here is just going to equal the 22. The 3 is the 3. Well, let me say 1, 3, and 2. I'm just putting dummy numbers in here to show you. These are the numbers you'll be using. Okay, and the standard deviation of the mean is going to be this number right here. Okay, so the upper control limit equals this plus this times this. The center line equals the mean. It's going to be 22. The lower control limit equals this minus 3 times the standard deviation of the mean. So that right there represents the upper and lower control limit, but you're using these numbers instead. And using these numbers instead of 1, 3, and 2, that will give you your answer for your homework. And the homework then will be one of these numbers for A, B, C, or D. Which one of those is correct? And notice I don't give none of the above. And so one of these will be the answer. Okay. And notice 22 is the center line for all of them. The upper control limit is going to be more than 22. The lower control limit is less than 22. How much more? How much less? 3 times the standard deviation of the mean. Okay. And that's how you do the arithmetic, and that's how you do that problem there. Okay. And then this question here, question 10. Let's move Excel out of the way here. We're done with this. Now in question number 10, here I'm talking about quality control. So if you go back to the Canvas, on the home page in mdharper.com, if you click that mdharper.com, come down to Operations Management. Okay, and then you come down to Videos, Forecasting, Linear Programming, Aggregate Planning, Inventory, Material, ABC, Scheduling, Project, Statistical Process Control, Introduction to Process Control Charts. If you click that video, I'm going to click it, go ahead and show you. It'll open up a video. Let me mute it. And this will go through and just give you an introduction, give you the definitions, and everything in this 8-minute and 44-second video will answer all those questions for you as you go through. So 8 minutes will give you the answer. Okay, of question, let me reduce this, minimize it, of these questions right here. They're all going to be part of that video. So look at that video to get the answer to these. And I did cover it in the lecture. When you look at the lecture notes, here, whoops, that's the homework. Lecture notes. Where's my lecture notes? Ding. There they are. Okay, got so many things open. I did cover that when I did the lecture with these notes right here, but that video also goes through and explains it. Okay, so this is the homework video, and I hope this helps. If you have any questions on this, make sure that you come to office hours Monday, Wednesday, Friday at 7 p.m. The link is in Canvas again. And if you actually go back to Canvas, and if you notice weeks 2 and 3, that's where we are. On here, we do have the Zoom office hours right here. You click this, and this will be the Zoom office hours with the different weeks here. So click that, and you're in office hours. It's going to be a Zoom. You click this, and it goes back to the videos. Now, when you go to the homework, okay, here's where you download the questions to get all the answers, and only then do you submit it. Okay, because the preview here, when you look at the preview, notice there are no answers here. All the answers are in the Word file. But then you get a letter answer, A, B, C, D, E, A, B, C, D, E, A, B, C, D, E, and then you click which one is correct. And so that's how I do this, okay, to make it easier, more straightforward. Now, on the videos here, notice I have a homework question here, and right after this, under here, I'll have a homework video. And this video link will be right there. Of course, you can't see it. You can't hear me say this because it's in the video. But this is where it's going to be for the other weeks as well, for all the weeks as we go forward. And I'll put these here as soon as we get done and as soon as I close out, which I'm ready to close now. That's all I have for this homework. And I'll do this for every homework assignment as we go through, just to work it through with you. I consider this a lecture. So the first lecture is explaining the concept and the definitions, terminology, a little bit on the use. This is the application. I'm showing you how to apply it. And follow along with me to solve all the problems, and then submit the homework at the end of the week, at the end, when it's the due date and time. That's all I have for today. I hope this helps. And between now and the next time I see you, take care.